So alright, this is the 2021 BHU Geology MSc Entrance paper. So we will be discussing this today. Okay, so basically the first question says we will be discussing this paper thoroughly, like we'll be discussing the options and we'll be discussing in detail. So if you think like you are getting some important points, please do note them down. Those will be really useful for you people. Alright. So the first question we have, which of the following is not a variety of gypsum? Okay, just a second. So it says not a variety of gypsum. So basically, always read the question twice, whatever you get. Never miss such kind of things. Always focus on parts if it is asking true or if it is asking for false, if it is asking not, is there or not. Like which of the following is not a variety. So always focus on these parts. Never get your question wrong by not focusing on these. Okay, so this is what you all need to do. You need to be wary of. So basically, gypsum's formula is chemical formula CaSO4 dot 2H2O. Okay, this is gypsum formula. It is hydrated calcium sulfate CaSO4 dot 2H2O. I will mention some of the properties, but before that, we will see the options. First one, it is given as wolfenite, satin spar, alabaster, gypsite. So basically here you can see there are four options. I can tell you that gypsum has a few varieties, such as there is selenite. Note these points down. Selenite. Okay. Selenite is a variety of gypsum. This is transparent and bladed crystals. Okay. Transparent and bladed crystals. We have another variety for gypsum as satin spar, which is given here in option. Satin spar. Satin spar is nothing but a pearly crystal, pearl-like, pearly, and also it is like fibrous masses. Satin spar. These are varieties of gypsum that I am mentioning here. Another variety we have is alabaster. So it is also given in option. Alabaster. Alabaster is fine grained. Alright, it's fine grained. It is lightly tinted variety. Tint is nothing but, as you can say, dhabba or dar, okay, something of that sort. Lightly tinted variety of gypsum. So basically, this alabaster is used and this is used widely for ornamental works. Right here, used for ornamental works. Okay. Now I mentioned satin spar, alabaster. Gypsite is nothing but a synonym of gypsum. This is a synonym of gypsum. This is also known as gypsite is also known as gypsum earths or earthy gypsum. Gypsum earths, or you can write it as earthy gypsum. Okay. This variety consists of dirt and sand. That is why it is known as earthy gypsum. It consists of dirt and sand. So here we have wulfenite as the right answer. So it is not a variety of gypsum. And first and foremost in this paper, I guess wulfenite it was mentioned as one of the options. Wulfenite is not any kind of a mineral. Like, I didn't even find about this at all. I haven't even heard about this. There is a mineral named wulfenite. So I think they must have tried to write this one, wulfenite, or maybe wulfenite is another name of this mineral, wulfenite. So wulfenite is nothing but a lead molybdate mineral. So this is not a variety of gypsum. Okay, it's a lead molybdate mineral. Lead molybdate. Write the chemical formula here. It is basically PbMO, that is molybdenum O4. Okay. PbMO4. So basically, the first one will be the right answer here. This is not a variety of gypsum, and I will mention a few gypsum properties so that it helps you. Like, if any question on gypsum arises again, it helps you. Like, basically, gypsum is, write it here. Gypsum is monoclinic. Just a second. Okay, so I will write it here only. Gypsum. So write these points. These are few points from where the questions may occur, like in match the column or in any way it can occur. Okay. So gypsum is monoclinic. It is biaxial positive. These are some of the properties that you must know. Biaxial positive. Its crystal class is prismatic. Prismatic class right here, which has HM symbol, that is Hermann-Morgan symbol, as 2 by M. That means there is a two-fold axis, and on this there is a mirror plane as well, which is perpendicular to the two-fold axis. 2, if it is written as 2M, that means the mirror plane is parallel to the two-fold axis. But here it is 2 by M, so the mirror plane is perpendicular to the two-fold axis. So this is the Hermann-Morgan symbol for gypsum. Okay. So this was basically some of the properties for gypsum. We'll erase this part here so that we can use it for next. Alright. So whenever you find, while solving papers, you find any question on minerals, any question on, I will say, fossils, okay, I will mention a website here. Always use this website. That is MINDAT, MINDAT, MINDAT.org. So always visit this website. You will get the complete details for the mineral, for any kind of fossil. Okay. What this website will tell you is about mineral properties, optical properties. Okay, crystallographic data you will get. Crystallographic data you will get. Alright. Then you will get geological environment. All these things get important in terms of knowledge and also in terms of exams. Then this website can also provide you details on XRD, that is X-ray diffraction, for that particular mineral, varieties of that mineral. So you will get the varieties, like here it was asked about gypsum, you will get varieties of any kind of mineral that are existing. Okay, the common associates you will get, what are the associates of that particular mineral or fossil, and also you will get significance in petrology. So this website is very exhaustive in nature in terms of information. So it is very informative. Use this website. Okay, whenever you come across any mineral or any fossil, so you can use this website. All right. So we'll move ahead with the next question. Okay. So basically, our next question says, how many crystal faces are there in hexoctahedron? How many crystal faces are there in hexoctahedron? Does anyone have any idea about this? Can anyone answer this? How many crystal faces are there in hexoctahedron? I will tell you a little hack also to get such kind of questions right. Okay. Now see, it is telling about hexoctahedron. What is octa? Does anyone know? What does octa symbolize? Octa means 8, right? 8. So that means this hadron has 8 faces. Now it says hexoctahedron. Hex means 6. So you just simply need to multiply this. That means it will come up to 8 6 are 48. 48 faces. Okay. So here we have fourth option, 48 faces. I don't know whose PDF is this. He has also chosen this option. I didn't choose anything in the first question, but it doesn't matter. Maybe he might have got many questions wrong as well, but we will always look at the right options. Here the right answer will be 48. In hexoctahedron, this is a little hack that you can have. If you get tris octahedron, tris means 3. That means 8 3s are 24. Then it will be 24 crystal faces. Likewise, okay, if you have, for suppose, can we get this? Hexahedron is also there. So in that case, we will have 36 crystal faces. Okay. So I will let you know a little bit more details on this. We'll write it here, note them down. Like, you have this hexoctahedron is the general form of isometric system. Okay, hexoctahedron is the general crystal form and general forms are the highest symmetry forms. General form of isometric, or you can say cubic, isometric or / cubic crystal system. This hexoctahedron is also the highest symmetry form. That means it has the highest symmetry possible in complete isometric crystal system. Now isometric crystal system is already the highest symmetry crystal system. Okay, and hexoctahedron is its highest symmetry form. That means hexoctahedron is the highest symmetrical form of all the forms possible, all the crystal forms possible. Okay, so Actually, we have in numbers, if we talk about numbers, we have in total 15. We erase this part, need a little bit more space. So in total, we have 15 isometric forms, or I can say cubic forms. There are total 15. So remember this number also. Maybe next time the question comes on this thing only, that how many crystal forms are possible in isometric crystal system. So in total we have 15 isometric or cubic forms. We'll write here isometric forms. Okay. So we'll mention some of the most common forms here. Now suppose the first, I'm mentioning here most common isometric forms. Okay. Here I will write about forms, have columns, forms. Here number of faces. This question was also on number of faces only, number of faces, and here we will write about crystal family. So the first most common form possible in isometric crystal system is cube. Alright, cube. How many number of faces are there in cube? 6. There are in total 6 number of faces possible in cube. What is its crystal family? It is 1, 0, 0. 1, 0, 0. The general notation is HKL. H is the coordinate axis on, like, the coordinate intercept basically. If you imagine an XYZ coordinate plane, so on x-axis H is the coordinate intercept, this part. Then we have K on the y-axis and L on the z-axis. Then we have the second most common form, that is octahedron. Octahedron has in total 8 number of faces, and the family is 111. 111. Okay. Then we have dodecahedron. Dodecahedron has 12 number of faces, 12, and this is 110. Then we have trapezohedron, or trapezohedron, however you can pronounce it, in whatever way. Trapezohedron. Okay. Trapezohedron can have 6, 8, or 12. So out of these three, any number of faces. And here we have, so while writing the general notation, we don't put this curly brackets. For trapezohedron, we have general notation as H, L, L. Okay. And this HL, for this HLL, we have H greater than L. So that means the K-intercept and the L-intercept both are same. Okay, so the Z-axis, the intercept we are having will be the Y as well for this case. Then after trapezohedron, we have tris octahedron. As I said, the shortcut is 8 into 3. 8 3 is 24. The total number of faces for tris octahedron is 24. Here we have HHL. Again, H is greater than L. Then the last of the most common forms is ex octahedron, that is the general form. The question was based on this only, ex octahedron. Ex octahedron has 48 number of faces, and since it is the general form, so it will be HKL. Okay, so any kind of intercept you can have. So this is it about this question, and these are some of the info that you can have. Okay, so many questions can be formed out of these info that I am providing here with each question. Okay, so try to note this down, it will be helpful for you all. I hope I am audible, right? There is no response, so it's getting okay. We will move ahead. Which of the following corals are not found in the Paleozoic era? Again, the question says not found. So here the options are A and B only, E only, B and C only, D only. So it is asking about corals. Alright, corals not found in Paleozoic era. That means you can go either ways. There are 5 corals, like coral varieties or coral subclasses that are mentioned here, okay, or families we can say. So if you know that which of these are from Paleozoic, in that way also you can get the question correct. If you know which of these are from Paleozoic, then you can get the one that are not from Paleozoic, or you know which of these are directly not from Paleozoic. That is the question itself. Okay, so we'll see like what age does these belong to. So Cephosmelia, basically the first one. Cephosmelia, the first one. It ranges from middle Triassic to Eocene. Okay, Eocene. So middle Triassic, Jurassic, Cretaceous. Triassic, Jurassic, Cretaceous is basically from Mesozoic era, not from Paleozoic. Alright. So this first one is not from Paleozoic, so this will be one of the options. That means, and you can see here 1, 2, 3, 4 the options that are given. A is only mentioned in the first one. So by only getting the A correct, you can get the right answer. First will be the right answer, A and B only, because A is only mentioned in the first one. Okay, nevertheless, we will see one by one. Isastria. So Isastria belongs to late Triassic to Cenozoic. Okay, late Triassic to Cenozoic era. So Isastria, basically these are mostly from Jurassic, Cretaceous, and this is the range. This I am mentioning range here, but mostly from the complete range is from late Triassic to Cenozoic, but it is mostly from Jurassic and Cretaceous. Okay, Jurassic and Cretaceous. So if such kind of questions come, you don't have much of the options. Like if you know it, you know it. If you don't know it, just skip the question and move ahead. Okay, most of the people won't get such kind of questions correct, because these are purely rote learning based. So if you know it, if you have read about it, if you have revised about it, and if you prepared so well that you had time to revise about the important fossils, then obviously you can go for such questions. Okay, so again, B. Isastria is ranging from late Triassic to Cenozoic. That means it is also not from Paleozoic era. That means A and B are not from Paleozoic era. Okay, then comes Phagocytes. Favosites is basically the extinct genus of tabulata coral. Okay? This is the extinct genus. Tabulata corals are one of the types of corals. You can also write tabulate or tabulata, tabulate coral. Extinct genus of tabulate coral, and it ranged from Ordovician to Permian. Ordovician to Permian. So that means it came into existence in Paleozoic era, right? And it got extinct at the end of Paleozoic era itself, that is Permian Triassic extinction and a Permian extinction, or you can say Permian Triassic extinction. So that means favosites are the part of Paleozoic era completely. Okay, and favosites are like one of the important corals. So do note this point down that it is an extinct genus basically, and it belongs to tabulata corals. Again, Syringopora. Syringopora is also similar. It is actually not similar, but exactly the same. It is also the extinct genus of tabulate coral, and its range is also exactly the same, Ordovician to Permian. Okay, so Syringopora and favosites are having the same lifespan, and both are the extinct genuses of tabulate corals. Then we have Calceola. Okay, I will write it here about Calceola. Calceola ranged from early Devonian to late Devonian. Again, Devonian is also part of Paleozoic era. Early Devonian to late Devonian. So it got its lifespan within a single period, not even an era. It's a single period. From early Devonian to late Devonian, Calceola was observed. Alright. So this was all about this question, where we had 5 types of corals and we had its life ranges. Then we have the next question, as given below are 2 statements. Statement 1, glass is formed in volcanic systems. Statement 2, glass forms due to rapid cooling that leads to more nucleation and less growth of crystals. Okay, so the question says, in the light of above statements, choose the most appropriate answer from the options given below. So here it is not asking about reason, it is just saying which of the 2 statements are correct or which of them are not correct. Like whatever, if it is correct, then we will go for first. Okay, likewise. So we will see each statement one by one. The statement 1 says glass is formed in volcanic systems. What do you say? Is it correct or not? Anyone? Anyone? Is it correct? So basically, see, glass, the statement 1 is absolutely correct. Glass is formed in volcanic systems. In plutonic systems, what happens is, with more depth beneath the earth, there is more time to form crystals. Okay, so you won't get glass in plutonic systems. You will get clear crystals that are developed. Okay, clear mineral crystals that are developed. So in volcanic systems, what happens is, due to the rapid cooling, due to the sudden cooling down of the magma, okay, it doesn't have enough time to form crystals. So there is no time to have the growth of crystals. In that case, we have glass that forms due to rapid cooling. So glass is obviously then possible in volcanic systems, because in volcanic systems, in extrusive kind of environment, if there is the magma propulsion suddenly happening in the extrusive environment, if it comes out suddenly on the top of the earth, on the surface of the earth, then it will cool down suddenly. It will not have enough time to form crystals. So that is why it will form just glass. Okay. So the statement one is correct. Glass is formed in volcanic systems. Then we have statement two. Glass forms due to rapid cooling that leads to more nucleation and less growth of crystals. Basically, statement 2 is also correct, because as I mentioned here, glass forms due to rapid cooling. Yes, right. Because if you have slow cooling, then it will not form glass. If there is slow cooling, you will have proper crystal growth. But due to rapid cooling, what happens is there is more nucleation and then there is less growth of crystals. So the statement 2 is absolutely correct. In case of rapid cooling, you have very less growth of crystals or no growth of crystal at all. And there is a lot more nucleation. Like there will be more nucleation but less growth of crystals. And when you have slow cooling system, there will be less nucleation but more growth of crystals. The crystals will grow more and much bigger in size. That is why we have larger grains when you have more time to cool the magma down. Okay, but with rapid cooling you have very finer grains. You don't have more time to cool. So that is why there is very less growth of crystals and there is very finer grains that can be expected in rapid cooling. So here what we get, statement 1 and statement 2 both are correct. Okay, so the first option will be right. Okay, moving on to the next question. So we have a match the column here, match list 1 with list 2. So the correct answer from the options given below. We will see one by one here. So it says first glacier. Glacier is basically, it is asking about a landform. Cirque is a glacier landform. Okay. If you don't know, Cirque is a valley. Basically, valley formed by glacial erosion. Also remember this, if it is an erosional landform or deposition. So Cirque is basically an erosional landform. When glaciers move like terminal moraines and moraines, you must have studied, when the moraines move, they erode the rocks nearby, and due to that erosion, a valley is formed. That valley, because of glacial erosion, is known as Cirque. Okay? CIRQUE. Glacier is related to Cirque. Then we have mature river. Mature river is basically related to meander. We'll again discuss meander here. Granite is related to exfoliation weathering, and young river is related to steep valley slopes. So let's see, A3, B4, C2 and D1. So A3, B4, C2, D1. So option 2 is the correct option. Okay. So let's see one by one. Meander is nothing but, it means a simple bend in a river channel. तो सपोज हम लोग एक रिवर चैनल है कोई, ठीक है, क्या होता है एकदम स्टार्टिंग के स्टेज में, जब रिवर अपने यंग स्टेज में होता है, ठीक है, यूथफुल स्टेज, what happens in the young stage, the flow is quite normal, like river takes such kind of a shape. Okay, but you have different kind of topography, right? Here maybe the rocks are more deep, here more shallow. So due to that, what happens is in the course of the river channel, it develops bends. Alright, like this. It will develop bends. So these bends are known as meanders that develops in the river channel. So these bends are known as meanders. I will let you all write down a few points here that are really important, and many a times we see questions coming up from these topics in many different exams. Okay, so basically you can write here like this: for a youthful stage of a river. Okay, so here we have space. I will write it here. Just a second. Make it clear. So for youthful stage of a river, तीन स्टेज होता है: यूथफुल, यूथ स्टेज, मैच्योर स्टेज, फिर आता है ओल्ड स्टेज. ठीक है, तो यूथफुल स्टेज पे क्या होता है? यूथफुल स्टेज ऑफ अ रिवर इज व्हेन वाटर फ्लो इज क्विकेस्ट. वाटर फ्लो बहुत क्विक होता है. वाटर फ्लो इज क्विकेस्ट. किस टाइप के हमको फीचर्स मिल सकते हैं? वी कैन एक्सपेक्ट इन यूथफुल स्टेज, सॉरी दिस इज एन एरो, waterfalls. Waterfalls, you can expect potholes. So these are the features that are expected in the youthful stage of a river. V-shaped valleys. V-shaped valleys are found in youthful stage. Okay, so these steep valley slopes, and we mentioned here young river. So these are the part of this only. V-shaped valleys. We have interlocking spurs. So these are some of the features that are found in a youthful stage of a river. Okay, this is SPURS. So all these are due to basically erosion. Okay, all these waterfalls, potholes, V-shaped valleys, interlocking spurs, these are due to erosion. Then what happens? Flow becomes gentler. धीरे धीरे फ्लो जेंटल हो जाएगा. अभी बहुत क्विक था. फ्लो becomes gentler. Okay, फ्लो आपका जेंटल हो जाएगा with time. With erosion, with time, flow becomes gentler. During mature stage, फ्लो जेंटलर हो जाता है, तो इसको हम कहते हैं मैच्योर स्टेज. ड्यूरिंग मैच्योर स्टेज, एंड द रिवर वाइडेंस. ठीक है, रिवर का पहले अगर कुछ इस टाइप का था, तो ये मान लो ये विड्थ, सपोज दिस विड्थ इज W, this will increase this W. Now what will happen is it will be a little bit gentle, and it will be like this with erosion. This will be the new W, that is W dash. So W dash will become greater than W. Okay, so the river will widen in the mature stage. Curves are characteristic of the middle stage as well. So here you can see the curves. These are characteristics of the middle stage. Right. Now what happens is on the inside of these curves, वैसे कर्व जा रहा है, on the inside of these curves, पानी ऐसे आया यहाँ से like this, it will hit this surface, right? Water will hit this surface. Inside of these curves here, what will happen is erosion will take place in this part. in this part erosion will take place. And in this part, what will happen is, outside of this part, there will be deposition in this area. Okay. Deposition outside of the curve. On the outside part, deposition will take place. Sorry, just a second. I'll explain it a bit more clearly. The width wala part, I guess you have got it. I will explain the curve part a bit more clearly. What happens is, now suppose there is such kind of a curve. There is such kind of a curve. Okay. So the water will come like this. It will come and then it will erode here. Okay. So the outside part, it will get eroded on the outside part, and the new part will be like this. So what happens is, this outside part of the river gets eroded. पानी ऐसे आएगा, it will erode and take the material out, and then the water will flow like this, and again it will erode here. Okay, again इस कर्व पे फिर से erosion होगा. So here on the outside of the river channel, erosion is taking place, and on the inside you can see the river channel ऐसा हो गया ना, तो ये inside in this part, this is basically deposition. Sediments get deposited here. This that I am currently shading. So this part on the inside of the channel, deposition takes place. Okay. So this is in the mature stage of a river. So this is what is known as the meandering river. Alright, meandering river. And after this, land gets the flattest during the old age stage. Flow और भी ज़्यादा gentle हो जाता है, and land gets flattest because of erosion काफी हो चुका है. Land flattest in the old stage. And also meandering river का आपको पता चल गया. We have got to know about meandering river. Also get to know about oxbow lakes, how they are formed. Now suppose you have such kind of a bend. Okay, ऐसा कोई bend है river में. Suppose you have such kind of a bend. Which time what will happen is, the water will try to find the shortest path. Okay, shortest path लेना चाहेगा, and with continued erosion, it will take the shortest path. What it will do is, now the river will be like this. Now the river will start flowing like this, and this part will get cut out completely. Okay, ये जो पहले bend था, this bend, it will get cut out. River will take the shortest route like this. This part will get cut out. So this cut out part is now a lake, right? Now it is a stagnant piece of water. It is not attached to the river. It is a stagnant piece of water. The water is quite stagnant now. And when the water becomes stagnant, that is when we call it as a lake. So this is now known as oxbow lakes. Oxbow the name because it looks like an oxbow, right? So this is now known as oxbow lakes. So oxbow lakes are formed from meandering rivers only. It's just that when the bend is such that water prefers to take the shortest route instead of bending. Okay, so when the curve is like, if the curvature reaches a certain threshold, like it is getting more and more curved, then the water will prefer the straighter route, right? So that is when the oxbow lakes are formed. Okay, so it was earlier a meandering river, there were meanders, but now it is an outflow lake. And here, surrounding this part, we call these as peneplains and what? Yeah, the peneplain deposition, basically. So the deposition has taken place, sediments are deposited now here around this river channel. So this is all about meandering rivers and its morphometry. Okay. We'll discuss these in detail when we study geomorphology. I'm trying to just cover as many basic concepts while solving questions. Alright, so we discussed about surf, meanders, and then we discussed about steep valley slopes. Then we have exfoliation weathering. Basically, exfoliation weathering is a form of mechanical weathering only, right? Mechanical weathering. Sometimes there have been questions like exfoliation weathering is which kind of a weathering. So it is, the options are mechanical weathering, chemical weathering, biological weathering. So basically exfoliation weathering is a kind of mechanical weathering, is a form of mechanical weathering rather, and it is formed due to, this exfoliation weathering is formed due to unloading or you can say release of stress in a rock. Release of stress in a rock. So now suppose a rock, there are some rock subsections, right? Like this. Suppose some rock beds are there, one over another. So suddenly these parts, suppose due to faulting or due to extensive erosion, these parts get removed. And only these parts are left now. So what will happen is there is unloading, right? This was loaded over it, but now it is unloading. Or you can also say there is release of stress. This was putting stress, lithostatic pressure on the underlying rocks. But now there is a sudden release of stress in a rock. So what will happen is this will produce, this unloading or release of stress will produce expansion joints. Suddenly the underlying rocks will feel the release of stress and it will get expanded. So there will be joints that are known as expansion joints, and this will cause exfoliation. Causing exfoliation. So what is exfoliation? Basically, in simple terms, exfoliation is nothing but peeling down of rocks. You must have seen onion. So the way we peel off the onion, exactly the same we have here. Okay, exfoliation is nothing but a peeling down of rocks. So आपने देखा ही होगा ऐसे होता है onion. What we do is ये साइड का ऐसा peel off करते जाते हैं ना, पार्ट हटाते जाते हैं, peel off करते जाते हैं. So ये एक peel के बाद the second peel is there, the third peel is there. So each of these are joints. These are expansion joints. Okay, so these are causing the exfoliation. And why is it happening? It is happening because of unloading or release of stress in a rock. Alright, so there is nothing chemical used over here, nothing biological. That is why it is a part of or a form of mechanical weathering. So I hope this is clear. We'll move to the next question. Match list 1 with list 2. Again, here we have polar soils, alkaline soils, lateritic soils, paleo soils. So basically, I think either you must have studied or not, I don't know. Paleo soils are the ancient soils. It is a term for, right here. Paleo salts. Paleo salts. Paleo salts are ancient soils formed on landscapes. Since these are ancient soils, so these were formed on landscapes of the past. Landscapes of past. Okay. So also these are found mostly buried in sedimentary record. Mostly buried in sedimentary record. So these are paleo salts. These are ancient soils basically. So by this we have paleo salts as buried and preserved soil. Polar soils are nothing but we have different soil horizons. Polar soils lack an obvious A horizon. There are horizons O, A, E, B, C. Okay, so these are different soil horizons. We have notes regarding this in our curriculum. You can visit that. And also, if need be, I will put up a separate video on this soil horizons. Okay. So OA, EBC, this A horizon and the O horizon, both these horizons are missing in the polar soils. Okay, so it also lacks an obvious A horizon. Then we have alkaline soils. Alkaline soils are nothing but the part of caliche. And then lateritic soils. Lateritic soils are basically because of extensive rainfall, warm climate. So when there is a warm climate and there is a cycle of extensive rainfall followed by warm climate, then we have laterite deposits over there. So laterite are like dark red iron deposits. Okay. So lateritic soils are due to are most likely in such kind of environment. So this environment signifies laterite deposition. Alright. So according to this we have A3, B4, C2, D1. A3, B4, C2, D1. Okay, the first one is only like this. So we have the first one as the correct answer. Okay. Move ahead. We'll just look a couple more questions for today. In the low pressure metamorphic sequence order of the rock facies as the intrusive body. In a low pressure metamorphic sequence order of the rock facies as the intrusive body that supplied heat for the metamorphism is approached is basically it is asking that suppose we have such kind of a graph. Okay. Here this is temperature axis, here this is pressure axis. So we have metamorphic facies assemblage, right? So it is asking in a low pressure. So for low pressure, this is pressure axis. That means somewhere this zone it is asking about. Around this zone. Okay. So this will be low pressure. If we go to this beyond this, here it is high pressure, right? So that is why it is asking about here low pressure metamorphic sequence order of rocks species intrusive body that supplied heat. So obviously the temperature will increase with time because the intrusive body is there, it is supplying the heat for metamorphism. So it is asking the facies sequence that is lying in this zone. Okay, let's see the options. Hornblende hornfels facies, pyroxene hornfels facies, Rabite epidote hornfels facies, country rocks. Like what will be approached first? Choose the correct answer from the options given below. Okay. So here we have, so first of all, we will have country rocks, right? country rocks, because when we have country rocks, only then uh, the intrusive body will supply heat to them, the country rocks, then the metamorphism will occur. So at first we will have D. Country rocks will be found at first. So country is basically near in terms here in the simple language. So D we have at first in two options, first and three, 1 and 3. So basically we have neglected 2, we have neglected 4. So country rocks, then what we can expect is, we can expect albite epidote hornfels species, that is expected to be found here first, albite epidote hornfels species. So you need to remember this graph basically. So this is the test of this graph only, nothing else. The question seems to be a bit complicated, but it is nothing but a test of this pressure temperature metamorphic species graph. Okay, we will get albite epidote hornfels species. Then will we get hornblende hornfels species or pyroxene hornfels species? Which will be first? Like after albite epidote, what we will get first? So basically, we will get hornblende hornfels first here. Then we will get pyroxene horn. Okay. So just refer this graph once, then you will get the thing that I am talking about. So it will be D C A B. So D C A B is in the first option. The first option will be correct. Alright. So there is nothing much that you need to apply your brain into such kind of questions. It's just that it is a bit complex, it seems, but it is directly based on the pressure temperature curve for metamorphic species. It's talking about low pressure, so we will go in this zone like this, not like this or not like this. Otherwise, what will happen is, this is medium pressure and this is high pressure. But here in question it is strictly mentioned as low pressure metamorphic. So we'll go this route. Alright. So then we have next question as the list 1 with list 2. Okay, so these are names of some of the scientists and these are the contributions of them. So you have to match the column who contributed in what. So basically I think everyone must be knowing that Charles Darwin gave the theory for origin of species. Okay. We have Carl Linnaeus, who proposed binomial nomenclature. We have family, genus, or species. We either write genus, species. And there are some conventions that it will be in italics. Some names will be in bold. The first letter will be in block letter. So these are some of the conventions. If you want to go in depth, read about binomial nomenclature. Linnaeus gave it. Okay. And then we have J. Lamarck and R.C. Moore. Moore R.C. we can say. Moore R.C. basically they provided a treatise on invertebrate paleontology, and J. Lamarck was the one who was first on theory on evolution, who first proposed theory on evolution. Okay, so here you don't need to apply a lot of brain. It is directly fact based, and if you remember, you can get them right. Now see, if suppose I knew only about these two. Let's see if we can get to the right answer. So Charles Darwin gave origin of species, that means B1. So how many options are there for B1? Okay, only one option is there. Option 1 is correct automatically. So that means if we know only one point that Charles Darwin gave origin of species, in this case you must have got the answer right. Okay. A3, that means Carl Linnaeus binomial nomenclature. C4, yes, and J. Lamarck gave theory, was first to give theory on evolution. D2. So even if you knew, like, the very first thing that I also knew was Charles Darwin gave origin of species. and only one option it is given, so automatically you can get in such a way. Correct. Alright. Then what we have here, statement 1. The corals are by and large marine creatures classified into rugosa, tabulata, and scleractinia. Statement 2. The scleractinians like rugosa and tabulata are found in late Paleozoic too. So we have to see which statement is true, which statement is false. Let's see. So the first one is basically correct. The corals are classified into these three classes. There are rugosa corals, there are tabulata corals, there are scleractinia corals. Then it says, and these are large marine creatures. So the statement is correct. Okay. Then it says the scleractinians like rugosa and tabulata are found in late Paleozoic too. So firstly, tabulata not found in late Paleozoic, found in Mesozoic mostly. So that means the statement is automatically a false statement. So we have statement 1 as true, statement 2 as false. Third option. Okay. So this tabulata being from Mesozoic, which we have already discussed in one of the questions above, you can see we discussed here. Yes. You can see here the tabulata ones. These are the tabulate corals, motivation to Permian. So these belong to Paleozoic, sorry. Okay, I meant to say here these scleractinians, these belong to Mesozoic. So it is already like contradicting the statement here itself. Alright. Then we have why a cephalopod is called so. Basically, because head is modified into feet, feet are modified at its head. Head is totally replaced by its feet, apparently locomotes on its head. Head and feet becomes a fused organ. So I guess the option will be T only. Okay, fourth option, yes. Because what cephalopod means, pod means foot and cephalo means head. And locomotes means it moves. So it apparently locomotes on its head. It moves on its head. Okay? So cephalopod basically cephalo is a term for locomotion, head locomotion. Okay? And pod is a term for foot. So basically head is playing the role of a foot here. That means they are moving through their head. It apparently locomotes on its head. The cephalopods are called such because of this activity only.